Hello all, welcome back to Datacraft Institute, your one-stop destination for data engineering, data analytics, and artificial intelligence. Have you ever wondered why do data warehouses like Snowflake, BigQuery, SAP HANA are so fast and they read billions of records so fast? Because they don't store data row by row, they store it column by column. So in this video, I will show you what column storage really means, how compression works, and how it's perfect for analytics in a very simple way. So let's start. Our story starts with a simple employee table. This table has 4 columns: employee ID, name, department, salary, and 4 rows. Okay. Now just make a note that employee 101 and 103 both belongs to the sales department. Moving forward, a traditional approach for storage would be to store the data for every employee or every row together. Okay, so all the data for Rahul is stored together. Okay, so this is a row, so every row is stored together. Similarly, all data for Anita, Vikram, and Neha, her employee ID, name, department, and salary is stored together. So in traditional row-based databases, all data for single record is stored together. This is excellent for retrieving an entire record like a user profile. Like you want to know the data for only Anita, it will be very fast because you are storing the data for Anita together. Okay. Now the analytical question. So if somebody asks what is the average salary, notice we only need the salary column here to answer the question. We do not need any other data for an employee. Okay. So in this case, the database will have to scan each and every block. It has to first go and check Rahul's salary, then Anita's salary. Okay. Similarly, Vikram and Neha's salary, then sum it up and then take the average, which will take some time. A more efficient way would be to store data by column. Instead of storing every row together in a block, we store data in a column. Okay. So employee ID, all the employee IDs will be stored together, all the name will be stored together, all the departments and salary will be stored together. Okay. Now let us ask the same question again. Select the average salary. In this case, we do not need these columns. We only need the salary column over here. Okay. So we will only select the salary column and we will calculate the average. This will make our queries very fast because we are skipping the unnecessary data. Okay. So the core principle is columnar storage makes data warehouse fast by reading only the columns needed for analysis instead of the entire rows. Now, what are the benefits? One is massive reduction in disk input output. When I say massive reduction in disk input output, what I mean is that generally data warehouses doesn't store everything in the RAM, random access memory. They will store something in hard disks or in cloud storage. Okay, so when you read only the required columns, only the necessary columns, which are fewer in number than your entire columns in your table, okay, are moved from the disk, okay, to your RAM, okay, resulting in faster scans. Okay. Secondly is compression. Okay. Now remember this particular table where we said that you need just make a note that employee 101 and 103 both belongs to sales. Okay. Now notice that sales occurs twice here. Okay. So sales is occurring twice. Instead of storing sales 2 times, we will store it once. Okay. Which is a compressed way of storing data. Okay, and we will also say the number of times we are storing sales. Now a common myth or a common confusion that arises in the minds of many people is that if suppose we are storing sales 1 instead of 2, how will the system know which employee belongs to sales? For example, here 101 and 103 both belongs to sale. Now if you will store data by column, okay, and you are storing sales only once instead of twice, how will you know that how employee 1 will be mapped to sales and employee 3 will also be mapped to sales? Okay, so this is a common myth that compression removes the row identity, but it is not the case. Okay, the truth is compression reduces the storage size. Okay, it reduces the storage size, it doesn't reduce the data but preserves the logical row alignment. Let us understand this. Okay, so this is the original employee table that you see here. So even before compression is applied, columnar storage relies on position. Okay, understand it this way, that every employee will be assigned a position. So 101 will be assigned a position 1, 102 will be assigned a position 2, 103 3, 104 4. Okay, position number 1 2 3 4. Okay, and There are multiple compression techniques we will explain two here. Let's start with dictionary encoding. The department column, which we have sales, IT, sales, HR, every department will be mapped to a number. We will build a dictionary out of it. Okay, that is why it is called dictionary encoding. Okay, and instead of storing sales, IT, sales, HR, we will be storing it as 1 2 1 3. Okay, so how is it compressed? How is compression accomplished? Now this will become our compressed column. Why is it compressed? Because instead of storing sales, which is like 5 characters long, we are only storing one, which is just 1 character long. Okay, so this will massively reduce the storage space. Okay, instead of storing IT 2 characters long, which is we are again storing 2, which is again 1 character long. Okay, so this is how data will be compressed. This is one of the techniques. Okay, secondly, the row relationship is perfectly preserved. So whenever the system knows that employee 101 belongs to position 1, the position which we calculated in this slide. Okay, so whenever it wants to select the department, it will check the compressed column. Okay, and the compressed column is the new column which was calculated by the system based on this dictionary. Okay, so the system will check the compressed column. It will go to the dictionary and fetch the corresponding value with respect to the key which it found in the compressed column. Okay, it will get sales. Similarly, it will go to 103, it will find 1 there, again it will go to dictionary, and again it will get sales. Okay, the value corresponding to 1 in the compressed column. The other encoding technique is run length encoding. Okay, when you have a long repeating sequence of the same values, the system can simply store the value and the number of time it repeats in a row. For example, sales is repeating 3 times, system will store sales in and the number of times it repeats. IT repeats 2 times, system will store IT and the number of times it repeats. Generally, data warehouses use multiple such algorithms to compress data. Okay, these are just two, or everything they are used in combinations actually. Okay, it's not just either or. So they will be used in combinations and a lot of storage will be saved. Okay, think of it like zipping a file. You have data, okay, when you zip, and when you unzip it, you have data back together, you have your files back together. Similar things happens. Columnar compression does the same thing to your data. Okay, what you do with zipping your file. Okay, now let us take an example of a query again, just to make sure the concept is clear. Select employee ID from employee where department is equal to sales. Okay, so first it will check the dictionary, it will check the key corresponding to sales, it will check the compressed column. Okay, so 1 1, which are the employees which are corresponding to those particular values. Okay, 1 1, it will fetch those employees. Okay, so I hope this particular part is clear. Okay, now moving on to the benefits. Okay, so now this, it is suited for demand of analytics. Columnar data storage is very useful for analytics. Okay, because analytics will hardly use select star queries. It will generally select the columns that are required for analytics. So by storing data by columns, it will dramatically increase the speed of the queries. Okay, now the library example, something to make your concept more clear. Okay, let's see the library analogy. Imagine a library full of books. Okay, each book is equal to 1 row. Okay, and each chapter or topic is equal to 1 column. For example, every employee will have a book, Rahul will have a book, Neha will have a book. Okay, and every employee that you saw in this particular table will have a book. Okay, and every book will have chapters for every columns, like department, salary. Okay, so now if you want to find out average salary, you need to read every book, okay, from start to the end, find the salary chapter for each and every employee. You have to read a book for every employee. Okay, this is row storage analogy. But in columnar storage is like a library where all the salary pages from all the books are stored together on a shelf. Okay, so now if you want average salary, you simply go to the salary shelf, read all the salary pages and ignore everything else. Okay, now remember this diagram. Traditional scan scans the entire rows, and columnar scan will only scan the row that you need, which is salary. So here, to get the salary, it will go from here and will scan everything, all the rows. But columnar storage will only scan the salary that you need. Okay, so thank you all. I hope you had got some insights into columnar storage. If you are a data engineering, data analytics, or artificial intelligence enthusiast, do subscribe to us, and let's see in the next video. Thank you so much.